grade 8, it's Mrs. Fell here. I'm going to do the memo with you for the grade 8 class assignment that you wrote on the 13th of March. Okay, so question 1.1, if you can follow on your question paper with me, you should be able to pull it up on your Google Drive folder on the website. So the first question was write 1 million as a power of 10. So if I need to write something as a power of 10, my base is going to be a 10, and then I count the number of zeros, and we should all know that there are 6 zeros. So it's 10 to the power of 6, and that got you your 1 mark. Then they said, round off the number 1,3892 correct to 2 decimal places. Now, if I want 2 decimal places, I want to see 2 numbers behind the comma in my answer. If I want the 2, I am interested in the 3rd decimal place to see whether the 8 will remain 8 or whether it will round up. Now, 9 is higher than 5, so if it's 5 or higher, this 8 is going to round up, which makes it 1,39. 1 mark. 0,71 times 10,000. That means I've got to move my comma. There are 4 zeros, so 4 places to the right, and that's going to give us 7,100 for my 1 mark. Okay, write 91,700,000 kilometers in scientific notation. Okay, in scientific notation, I'm only allowed to have one natural number in front of the comma. It makes it scientific notation is meant to make our life easier. It's a quicker way to write really big numbers. So I'm going to write my 9 down. I'm then going to put a comma behind the 9 and write any other natural numbers that fall in the rest of that big number. And then I'm going to count the number of places. There's an invisible comma at the back of this 91,700,000. So I'm going to count how many places. So that's 3, 4, 5, 6, 7 to get that comma behind the 9. So then I say I've moved it 7 places. So that's 7 tens essentially that I've moved it. So that's why the power question relates very much to the scientific notation question. 1 mark for the 9,17, 1 mark for the 10 to the power of 7. Question 2. Okay, we were given this algebraic expression. In the first question, 2.1, they said list the variables used in the expression. So the variables are my letters of the alphabet. So I've got an A, B, and a C in this expression. So you had to write all 3 of them down to get your 1 mark. Then 2.2 said how many terms are there in the algebraic expression. So this negative 5a is 1 term. The positive 3b is another. Negative c or negative 1c, and then the plus 17 at the back. So technically you're counting every term where you see a plus or a minus sign, that is a new term. So I have got 4 terms for 1 mark. What is the constant term? So the constant term is the only term without a variable. So 17 is my only term on its own. And the reason it's going to be constant is because if it's connected to a variable, its value can change because the variable's value can change. So the constant term is going to be 17 or positive 17 for 1 mark. 2.4, give a reason why it's referred to as a constant. Okay, why is it referred to as a constant? Okay, one of 2 reasons. So we're going to say either its value will never change. I'm just writing this in shorthand because of my space. Or it is the term without a variable. Okay, so either one of those 2 would have got you your single mark. Then lastly, what's the coefficient of A? I go and I look, what is the number connected to the A? In other words, right up against the A. It's a negative 5, not just a 5. I cannot forget about this negative sign in front, and that will give me my 1 mark there. My instruction in question 3 is simplify fully. All right, so I want to make these algebraic expressions Look as simple as possible. All right, so 3.1, I've got y plus y plus y. Now, guys, I can only add or subtract what we call like terms. So let's say that the y's are yo-yos. So as long as they are all y's, I'm allowed to add them. Now, if I've got a y there, how many y's do I have? Well, if I've got this Cokie in my hand, how many Cokies do I have? I have got one Cokie. So if I've got a y sitting there, I've got one of them. So I've got another one there and another one there. They are all like terms. And now even highlight the positive in front of the one because it tells my brain, what am I doing with it? Am I adding it or am I subtracting it? Well, I'm adding all three here. So I'm going to have 3y. And that'll give me my single mark. Then we're multiplying. Now, multiply is more powerful than plus and minus. So now I don't have to have like terms. So I am allowed to multiply these. Now, can I multiply 5 and 7? Yes, I can. So 5 times 7 is going to give me 35. A times B, the simplest way to write that is we glue those together. And that is my answer for 1 mark there. Okay, then I've got 6mn minus 2nm. Now, the little trick here is that they look a little bit different. But if I've got an m times n, and I glue them together, yes, I do get mn. If I've got an n times m, yeah, I can write nm, but we've taught you that the correct way to write in algebra is in alphabetical order. So really they are the same. They're like terms, okay? So I'm going to say here I've got 6mn minus 2nm. It's telling me what to do with the 2. 6 minus 2 is 4mn for 1 mark. All right, 3.4. I've got a few different terms here and I'm seeing A's and B's. Now those are unlike terms. So I'm going to group my A's with colors. The colors are so helpful here. So I've got a 3A, which is a positive 3A. Then I have to subtract 5A. Then I'm starting on negative 4 on my number line and I'm adding how many? It's a 1 there. All right, so what's 3 subtract 5? It's going to give me negative 2a. Then I'm starting on negative 4, adding 1, moving to the right. So that gives me negative 3b. So I'm going to get 1 mark there and 1 mark there, giving me my 2 marks. Okay, 3.5 was the tricky one. It was a higher order question. So what do we know about BODMAS? I know it looks a little bit overwhelming, but I can see brackets. Those must definitely happen first. So 4m plus 3m, are they like terms? Am I allowed to add them? Yeah, they are. So how many m's altogether? 7 m's. All right, then I've got to multiply it by 2. I'm not going to do that, but for now, I'll sort that out with the 7m in the next step. Minus 4a, that's a minus, but now I'm seeing a 3a multiplied by a 3m. So I am actually going to do that next because times is more powerful than the subtraction here. So I'm going to say negative 4a I've written down plus 3 times 3 gives me 9. And then a times m, I glue them together. All right, so your first 2 marks came from the 7m, doing that first, and then the multiplying to get your 9am. Next step, can you see the multiply there? That's going to be my next thing to sort out. So 7 times 2 is 14. I'm just going to write the am in alphabetical order. Let's write the negative 4a plus 9am. So where's your mark going to be there? It's from multiplying. And then lastly, I'm going to add my like terms. So I've got a 14am and a plus 9am. And that is different to the a that we see in the middle. So 14 plus 9, 23am. And my 4a tags on the back there. So I've got 1, 2, 3, 4 marks for subtracting those correctly. Right, 3.6.1. This was about Sam simplifying an expression in an incorrect way. All right, so we told you what step 1 is that he wrote down, and then step 2. Okay, so there's your expression at the top here. The first thing we had to do was explain Sam's mistake. All right, can we see that there's a multiply here, a minus and a plus sign? So once again, when I see my different operations, I have to remember the rules of BODMAS. I don't see any brackets, but I do see a multiply. So this over here is going to have to happen first. Now that is where he went wrong. Can you see that? He went the 2x minus the 3x first to give me the negative 1x, when he should have multiplied the 3x by the 5 and then sorted out the rest. So explain Sam's mistake. Okay, so you either needed to say something like he didn't follow BODMAS. Okay, or what did he do? He subtracted before multiplying. And that is where he went wrong. So he went wrong in step 1. Now you'll see actually in step 2, negative 1x times 5, so according to what he did, is negative 5x. Now that's called a continued accuracy mark. When you see a tick with a CA, that means continued accuracy, because from your step, which was incorrect, you have done it correctly. So we don't take away another mark, because that answer is wrong. Okay, so simplify the expression correctly. So we are now going to multiply first. We're going to write the 2x. Then we're going to say 3x times 5 is 15x. Remember, your negative sits in front. Plus 5x y. Okay, are we seeing like terms? I'm seeing a 2x here and a negative 15x. 2 minus 15 gives me negative 13x. Add the xy, and that is your answer, because they are unlike terms. So here you will get a mark for your negative 15x, and then for adding correctly, and you will see a CA there because it's continued accuracy. All right, let's jump to question 4. 4.1, we had to write algebraic expressions for these phrases. In other words, we're not going to get a final answer like 10. We're going to get an answer with y's and x's or other variables in it. So if I say subtract 5y from 2, lots of us just said 5y minus 2. But if I'm saying subtract 5 from 10, I'm going to write 10 minus 5. So your answer for this one is going to be 2 in front minus the 5y. And that gave you your 1 mark there. Okay, 4.2. If John is X years old now, how old will he be in 4 years' time? Now, lots of us just group that 4 and the X and we say 4X, but let's just put a number in place there, because often that helps our brains. So if John is 5 years old now, how old will he be in 4 years' time? Ask your brain, what are you going to do? You're going to add the 4. So if he's X, we don't know how old he is. So we're going to say he is X plus 4 in 4 years' time. And that gave you your 1 mark there. Question 5 was the photo frame. So they say write a simplified expression for the perimeter of the rectangular photo frame. Now, I don't like to get fancy with formulas with perimeter. We need to understand that if they ask for the perimeter of anything, we add up all 4 of the sides. Okay, so they have said to me that the length of the photo frame is 3x plus 3, and then the breadth of the photo frame is 2x minus 1. So there's 2 ways of writing this, okay, but most of us did this. We did 2x minus 1. Then we added another 2x minus 1. So those are my 2 breadths. Then I need my lengths. 3x plus 3, add another 3x plus 3 for my 2 lengths. And then I'm going to work that out. Now, I don't really need the brackets there, and I actually haven't left enough space. But when we're adding, we're not going to need the brackets. So I'm going to collect my like terms. So I see an x there, I see another x there, another x there, another x there. Then we have got a negative 1, a negative 1, positive 3. Okay, So we're going to say 2 plus 2 is 4, plus 3 gives me 7, add another 3, 10 x's. Okay, we're starting on negative 1, we're subtracting 1 to get negative 2, add 3, positive 1, and add another 3, positive 4. So there's your simplified expression. This is an expression, but there's your simplified expression. Okay, I'm just going to write above here what other people did. They said we've got 2 of those, which are your breadths, and then we've got another 2 of those. And then you would have got exactly the same answer, so you would have got your marks if you did that as well. 5.2, determine the actual length of the photo frame if x equals 4 centimeters. Now, this was a reading issue. If they say to me actual length, are they talking about the perimeter? No, they're saying the length. So that's why it's quite a tricky thing, because we're not great with our reading. Okay, so we're going to take this expression and replace the x. It's called substituting 4 into the place of x. So instead of writing that x, I'm going to replace it with the 4, and I always replace with brackets. Okay. You will see in one of Mrs. Smith's videos that she shows you the difference between writing a multiply with brackets or a dot in between. So go and check out those videos, and then I can work this out properly. So 10 multiplied by 4 is 40, and add another 4 gives me 44 centimeters. So what we did here is whatever you wrote down here, we took that algebraic expression, and if you substituted the 4 correctly, then you got the marks there. So this was a substitution mark, and then this was a continued accuracy mark from your expression in 5.1. So as long as those followed, you got your 2 marks there. Okay, now that was actually the perimeter. I'll tell you what we did. We accepted if you wrote down the perimeter, because lots of us actually thought that the length meant the perimeter. But what was the expression for the length in the photo frame? It was 3x plus 3. So when I substitute the 4 in there, I've got 3 multiplied by 4, add the other 3, which actually gave me 12 plus 3, and that gives us 15 centimeters. So this was actually the correct answer, but we were a little bit lenient there and gave you the marks if you did that over there. Okay, question 6 was our problem solving question, and that's why it looks a little bit different. We haven't worked on it in class before, you've seen it now, and that's why it's problem solving. So it said there are 2 possible numbers that can be used in the place of x to make this statement true. So this actually is an equation. So determine these 2 numbers. So you would have had to play around with different values that would replace the x in order to make this statement true. In other words, when you replace it, your answer must equal 15. So your answers were -5 or x can equal 3. Now, the trial and error method is, if you were playing around here, you would have seen that if I replace x with -5, I put the squared behind it, put my 2 down, and I replace the x with -5. Okay, we need to actually check whether it's 15 or not. So -5 squared is actually -5 times -5, which gives me a positive answer. Then I've got positive 2 multiplied, because I've got the brackets there, by -5, which is actually a -10. It's a negative answer. And does 25 minus 10 give me 15? Yes, it does. Okay, so that's why -5 was your one correct answer. All right, then we've got x equals 3. So let's test it. 3 in brackets, we're going to square that. Add 2 multiplied by 3. Let's check. Does it equal 15? Okay. So what is 3 squared? It's 3 times 3, which gives me 9. Then I'm going to say this is 2 multiplied by 3, which gives me 6. Does that give me 15? Yep, it does. So there's my second answer. So this one just out of 2 marks. So you just had to get them correct, whether you did this or you didn't write it down. It was for your answers. All right, I hope that helps. That was your full 30 marks for the assignment.